Hello and welcome to episode 3 of this series. In this episode, I want to talk about nested schemas as well as transformations. And we'll see how our application can benefit from these two, concepts. So first, let's, learn how we can use nested schemas in Zod, how we can use transforms and refines for advanced validations, and how we can improve data quality with automatic type transformations. So in our application right now, if I take you to the app, to the single schema that we have, you see that author is of type string. But in this episode, we want to change that. We want the author to be, kind of a separate type. And then we kind of reference that author type inside of our book schema. So author as a nested object. So currently, as I told you, author field is just a string inside of the schema that we have for books. Instead of just collecting the author's name, what about, collecting more information about the author, like for example, the name of the author, the birth year, and the nationality with these, for example, rules, right? So the book schema will now contain an embedded author object. We have, by the way, the same concept, for example, in document databases, like for example, MongoDB. So if you want to learn more about them, check out the course that I have on the channel about, MongoDB. Now, nested schemas in Zod. You can define schemas inside other schemas. Take a look here. We have a separate schema for author with name, birth year, nationality. Based on what we discussed in the previous episode, I expect you to kind of understand what this schema is doing. So I'm not going to explain it anymore. Then we've got the book schema. So two separate schemas. Now, inside of the book schema, we are referring to the author schema. You see the name author schema has been referenced here. So the author property or key is not of type string anymore, but of the schema type. So let's understand two new concepts when it comes to using nested schemas: refine and transform. So what is refine? Refine lets you add custom validation rules beyond the built-in ones. So we know that there are some, built-in validations, like for example, number, greater than, lower than, right? Now we can use refine to add more customized validation rules. It lets you write your own logic to decide if data is valid or not, and you can apply it on any schema, including nested fields. Let's go through an example. Imagine you want to make sure an author's birth year is not only between 1900 and 2020, but also that the author is at least 18 years old at the time of the, at the time they want to publish their books. So we can do this custom, we can implement this custom validation using refine on the author inside of the book schema. Again, remember, refine, as the name kind of suggests, allows you to implement custom validation logic. If the validation rules that are built into the library are not enough for you, you can define your own validation rules. So again, take a look at the validation rule we have defined for author. So for author, we are using author schema, right? The type of the schema, and then refine, and then we are creating the validation rule here, author and context. So if author.birth year is greater than context.parent -1, and context.parent is of course the book, right? So this is the publish year of the book. So context.parent in this block of code takes us to this year property. So if it is greater than that, return false, it is invalid, the validation failed because author is too young when the book is being published. Otherwise, return true. And then the message will be this one: author must be at least 18 years old when the book is being published. That was the concept of refine. Again, it allows you to implement custom validation. What is transform? Transform lets you change or convert the data after validation. For example, you might want to format a string or calculate a new field. So the transformed data is what you get back after parsing. Let's go through an example. Suppose you want to transform the author's name to always be capitalized when you receive it. So you can go to your schema, and in your name, key or property, of course, it needs to be of type string, and then you are using this transform. So transform, you take in the value for name, and then you trim it, and then you change it to uppercase. So again, transform allows you to convert a value that you are receiving for a property inside of your object. After parsing, the name will automatically convert to uppercase, no matter how it was input. Now, how does this work with nested schemas? You can use refine and transform in nested schemas. We have already talked about nested schemas. So you can refine a nested schema or any nested field to add extra checks that depend on other data, and you can transform fields inside nested schemas to clean or shape the data before you use it. So we will see these in action. Just remember that refine is for implementing custom validation rules. Transform is to convert or transform the data in your object. And of course, you can combine them with nested schemas. Now, what I want to do is to define the author schema and update the book schema. Right now, we have only the book schema, right? But we are going to, of course, change that. The author schema is this. Take a look. So we've got the author schema, we've got the name, this is the validation rule, we've got the birth year, as you can see here, some validations, for number, for greater than, lower than, and then the nationality. Let's go ahead and create this. So inside of my folder for schemas, I'm gonna create author.schema.ts. I'm gonna write the code. Okay, of course I need to import Zod. Now let me turn off my auto completion suggestions, and now we can continue. So let's understand each line of code. Of course, we are already familiar with this schema mostly. So the name field must be a non-empty string. If it's empty, the message will be author name is required. Then we've got birth year. Birth year again has this number field, and birth year must be a number. If someone enters a string like this, for example, Zod will throw the error, birth year must be a number, and it must be between this range. So greater than equal, lower than equal. And then finally, the nationality. It must be a string, and it is optional. So if it is not present, we won't issue an error. If it is, it must be a string. Now we want to update the book schema, right? The book schema is going to get updated, and the author is going to be a nested schema in here. So let me go ahead and update the schema for the book. So book schema. I am going to get rid of this previously written code. I'm going to zoom in a little bit, and I'm going to write the code for this new version of my book schema. The title needs to be a string with at least one character, and the error is going to be title is required. Then the transform that we are using on the title is trimming that. So we're using transform. We kind of talked about transforms. Transforms allow us to kind of do transformations on our values. Then we've got year. Year, we are going to course it to number. It must be an integer, and then greater than, and then lower than this date. And then we are importing the author schema. Let's talk about the code. So first we are importing Zod, of course, and the author schema, which we previously defined. Next, we are creating the title field. So it must be a non-empty string. We are going to transform it because we want to remove both the leading white spaces as well as the trailing ones from the input before validation. So if this, for example, is the value, we are going to trim it. Then check out the year field. So z.course.number means that if the input is a string, like for example this, Zod will automatically convert it to a number. So this is the z.course.number. This is useful with HTML input fields, which will always return string. And then you've got the integer. It must be an integer, no decimal, for example, and it must be within this range. And then finally, the author field, which is a nested field, right? So instead of redefining the author fields, we are reusing the author schema, which we previously defined. Again, don't repeat yourself, dry, which is a very important principle in software development. This is a very modular approach. So if, for example, the number of types that the application wants to work with, increases, we do not have, we will not have a problem. We will have like a modular, modular structure, defining different schemas, and then reusing them. So better readability, of course, easy reuse of schemas, and clean validation logic across forms. Now, update the form UI. We want to make some changes to the, add book page, which we defined previously. And the reason is that right now, the book schema has this nested object inside of it, the author schema. So author is no longer, a string. So if you, for example, take a look at the, let's say, author, we are getting to the author.name. Name is a field on the author, schema. Then we've got the, for example, year, which is the author.birth year. So the nationality is, of course, going to be, optional. And those are the changes that we need to make to the, add book form. So let me go ahead to add book, and this is the code that I have right now. So this is what we talked about in the previous episode. And if you, for example, take a look at the author, because in this context, author is not a nested schema, we are getting to the author through this syntax. But right now, author is a nested schema inside book schema. So we need that dot notation. So let me get rid of this code and, write the add book component from scratch. So again, getting the register, handle, submit, and using use form hook, creating my unsubmit, and then the template. The template is the place where we are going to use dot notation to get to the nested type inside of my book schema. Here, take a look at the author. So the input will be register author.name. So go to the author, which is a nested type inside a book schema, and then the name field. And then get to the year. Again, author.birth year. And finally, the nationality, which is optional. So again, author.nationality. So these are the changes that we need to make. Of course, I need to do the imports, for example, for the, add import, for the resolver, for the book schema, add import for book schema, and of course the type. So we need to, create the type. So for the type, I can create the type here. And now I need to import Z from Zod. And now I think I'm good. So let's continue with the notes. let's understand the new version of the code we wrote for the component. So again, as I told you, because author is now a nested kind of field inside of the book schema, we need this dot notation. So check out the author field. This is the input field. We are getting to that, author property first, and then we are showing, or we are binding to the name property on that author object. And then we've got the, errors, exactly, the same dot notation here, as well as for the, the first part, which is checking whether there is an error for the name property. Nested field, author.name, display nested error message if present. Next, we've got the year. So again, something new is this value as number true. So value as number true, this converts the string input into a number, and it is going to validate it to be between, this range, within this range, based on the rule that we defined in our schema. Finally, let's look at this last field for nationality. Again, we're using dot notation to get to the nationality of an author. This field is optional in the schema, so it won't cause errors if left blank. And that was it for this episode. In this episode, I wanted to discuss the concept of, nested schemas coupled with, transforms and refines. And also we implemented that in our project. Thank you so much for watching this episode. I'll see you in the next one.